All right, welcome to a little lesson on sketching planes. Now, in the last lesson, we saw a little section where we were generating ordered triples using a multivariable function with three variables in the form of f of x and y. Um, and we were plotting the points, and you probably noticed that they were a little bit harder to predict in terms of the pattern and harder to see what was happening. And I asked the question at the end of the last lecture, which was, what would happen if we keep plotting more and more points using a three variable function? And what would happen is that those points would eventually, if you plotted enough of them, they would look like they were connecting and they would form a surface that goes off infinitely in every direction. And what we call that surface is a plane. Um, Now, here's some examples here of very important planes that you should know about because they come up a lot in mathematics. Uh, the first here, over here, is the xy plane. Now, this represents all of the points that are on that have x and y values, but the z value is 0. So over here, we might have 2, 1, and 0. And now there are infinitely many points within this xy plane. Over here, we have the zx plane. Now this represents all of the points that have x and z values, but the y value is 0. So we could have -1 and 2, which would be, maybe right about there. Now, once again, there are infinitely many points on this plane, and it goes in all directions. The third that we might mention, this is very important, is the ZY plane. Now, this one has, you guessed it, 0 for x, and it has a y and z value, and this represents all the points. Now, we can move these planes around a little bit. You could think about taking this xy plane here and maybe shifting it upwards. Okay, so let's think about what would the plane look like if all of the z values were, so we have x and y values that can be anything, but the z value is always 4. What would that look like? Well, in order to draw that, we'd have to try to use a bit of our geometry skills. And I don't know if I'm doing the best job I could, but you can imagine a plane here that comes right across and touches at z equals 4, and we have all sorts of points in here that are connecting, creating a plane of points in 3 dimensions. So we can move these planes around. Here we could do y equals 2. So we have x values, y is always 2, and z is always, well, z can be anything. So right here we have y is 2, and that would be all of the points that are along this plane. So filling out right here. Now let's go back down here. Let's think about making one in the ZY plane. Now you have a piece of paper. You could always pause this and give it a go yourself. Try to draw when x equals, let's say, this is a 2 right here. This is a 4 right here. Let's say when x equals 4. What is that going to look like when we have 4? We have y values. We have z values. Draw the plane that represents all of the points within the 3-dimensional coordinate system that have x values of 4 and any possible y and z values within the real number system. Okay, so I'm going to draw that for you here. So x is 4, and we want to extend that upwards into 3 dimensions. There we go. And we're doing a lot of sketches in this section, but there it is. Okay, so planes. We're moving from lines, right? A line, right, to planes, where we extend out a line. Okay. Excuse me, I got a bunch of work here that I'm going to erase. Okay, this next section then says the easiest way to get a quick sketch formed by a three-variable equation is to find the x, y, and z intercepts. Plot these points and connect them and lightly sketch the plane. So similar to equations in two dimensions, if we want to find the intercepts, that is where the plane in this case is touching the x, y, and z intercepts, we can use similar strategies. And a very easy way to sketch planes is to find those points, plot them, and connect them, and start to draw the plane and just kind of visualize what the plane might look like. Now, you do have to use your imagination a little bit to extend it, because when in drawing in 3D, it's a little bit tough. Sometimes we mix up what's behind the origin, what's in front of the origin. Let's just use this strategy to get a sense of what's happening. So let's find the x, y, and z intercepts, plot them, and try to draw a little plane. You can pause the video right now and give it a try yourself. All right, so the first thing we're going to do, I don't know, let's find the z-intercept first. Z-intercept, that's going to be when x is 0 and y is 0. So that's going to be negative 2 times 0 plus 0 minus 2, which is going to give us negative 2. That gives us the point 0, 0, negative 2. So we have 0, 0, and down 2. There's our first intercept, x-intercept. Now, this is going to be when z is 0, and we want to know what x is when y is also 0. So here we're going to end up with 0 equals negative 2x minus 2. Solving for x, we have 2 equals negative 2x. Divide by negative 2. We have negative 1 equals x. Now this gives us the point negative 1, 0, 0. So that's negative 1 and 0 and 0 right there. Finally, let's get our y-intercept. That's going to be z is 0, x is 0. Now what is y? Negative 2 times 0 is 0. We have 0 equals y minus 2. Add 2 to both sides. 2 equals y. That gives us 0, 2, 0. 0, 2, 0 is right here. Okay, and now what we have is 3 points, which can kind of give us our bearings here. In our x direction, we're negative, y direction positive, and z, we are negative. So we're going to connect these points, and that's going to help us imagine a plane. You can imagine it going off more in this direction, upwards in this direction, downwards in this direction. A plane that extends out from that little triangle. Now you do have to use your imagination a little bit to try to visualize it, but that's the general idea. Oh, don't look at that. Now it's your turn. Try a couple sketches on your worksheet, and then try this last question, which asks you to find the intercepts as well. So pause it, and if you want to come back and watch the rest of the video. All right, welcome back. Hope you did well. All right, so we have 0, negative 2, 0. That's our y-intercept. So negative 2 is here. X-intercept 4, 0, 0. And z-intercept is positive 1. So we have a plane right here, which is kind of angled off in this direction. And you have to imagine extending that out. On our next one, this is x, this is y, this is z. So we have 1, 0, 0. That's right here. We have 0, 3, 0. That's here. And we have negative 2 here. So, okay, this one follows right along the x-axis. Now, this one's an interesting one. Oh, I just made a mistake. Silly Mr. McTavish. Sorry, that's 1, 0, 0 is our x. Y is 0, 3, 0. And z is negative 2. Okay. I knew that didn't look right. but no time to make a totally new video for that. Here we go. Connecting these points. This is underneath the origin. This plane is going to kind of extend out in this direction and this direction and this direction, and extends out in all directions, but try to visualize where that's going. And here's our final one. We're going to find our z-intercept, we're going to find our x-intercept, and we're going to find our y-intercept. So that is f of 0. 0 equals 2 times 0 minus 2 times 0 plus 4, and that's going to be 4. So 0, 0, 4, that's way up here. The x-intercept is going to be 0 equals 2x minus 2 times 0 plus 4. Solving for x, we get negative 4 equals 2x, divide by 2, x equals negative 2. So that is the point negative 2, 0, 0. So that's right there. And for our y-intercept, we got 0 equals 2 times 0 minus 2y plus 4. Solving for y, we get negative 4 equals negative 2y. Divide by negative 2, y equals 2. So y equals 2 is right here. And that gives us kind of a steeper looking plane. It kind of goes off from here. Okay, if you've completed this, have a look at the worksheet entitled Lesson 1 Practice for some more problems and practice. Thank you very much.